Okay, so on your unit circle, what would you say that the sine of 30 degrees is? I gotta project here. Boom. There we go. Sine of 30 is 1/2. What is the cosine of 60 degrees? 1/2. Okay. Now, what is the cosine of, let's just go cosine of 30 degrees once. How about the sine of 60 degrees? Now notice, okay, these two have the same answers. These two have the same answers. Okay, so let's deduct something else. What's the sine of 45? Cosine of 45. So in the first quadrant, if we take the cosine of whatever angle, or 90 minus whatever angle, x, what should that equal? The sine of x. Okay, just look at that once. If we took the cosine of 90 minus 60, we get the sine of 30, or yeah, the sine of 30. The cosine of 90 minus 60 is a sine of 30. And the cosine of 90 minus 30 is a sine of 60. And the cosine of 90 minus 45 is sine of 45. Okay? Could I also put it like this? Yes. Okay? Because those all meet up. Okay? So, what if I told you, and this is a total fabrication, what if I told you that the sine of 5 degrees was equal to 0.2136? What would the cosine of 85 degrees be? 0.2136. See how sines and cosines are related in that fashion, okay? Sines and cosines are also related when it comes to um, different areas of the quadrants. Now, in this one, this is not exactly what I was doing up above, but it relates to it. It says find the exact value of sine of A if the cosine of A is 5/7 and we're in quadrant 4. Okay, so if we're in quadrant 4 and I draw my triangle, where should I draw from here? Up or across? Up. You always go to the horizontal line, horizontal axis. If the cosine is 5/7, what two parts of the triangle do I know? We have x, y, and z. What two parts of the triangles do I know? X and z. X and z. I know x is 5 and z is 7. So how do I find my other part? What? Pythagorean Theorem. 7 squared is 49. 5 squared is 25. 49 minus 25 is 24. The square root of 24 is the square root of 4, square root of 6, which is 2 square root of 6. Now, would this 2 square root of 6 be positive or would it be negative? Negative in this quadrant. So the sine of A in that quadrant is negative 2 square root of 6 over 7. A little bit complicated to find. but not the end of the world. Okay? Now, find the cosine of alpha, given that the sine of alpha is 2/7 and the cosine is negative. Where would the cosine be negative and the sine be positive? Looking at your unit circle. Where is x negative and y positive? Quadrant 2. So I must be in quadrant 2 somewhere. So I draw it out here and draw it down. Now the sine is 2/7. What two parts do I know? The vertical line is 2 and the hypotenuse is 7. So what's 2 squared? 4. 7 squared is 49. 49 minus 4 is 45. Square root of 45 is the square root of 9, square root of 5, or 3 square root of 5. Now, would that be positive or negative? That 3 square root of 5. Negative in this situation because we're going to the left. So the cosine of A is negative 3 square root of 5 over 7. Okay? Are we good there? Okay, reference angles. Okay, a reference angle is how far away you are from the horizontal line. Okay, that's your reference angle. So if we're talking about 315 degrees, 315 degrees on your unit circle, you can see is down there somewhere. Actually, more accurately, it's like that. Okay? How far away are you from the 45 or from the x-axis? 45 degrees. So your reference angle is 45 degrees. Okay? You're right here and you're 45 degrees. Now, what's 45 degrees in terms of radians? Pi over 4. You can get that off your unit circle. 5 pi over 3. Where is that on your unit circle? What quadrant? I've got a 3 and I've got a 4. Quadrant 4. It's this one right here. Okay? That's 5 pi over 3. How far are we away from the horizontal line in radians? Well, how far is it completely around the circle? It's 2 pi, right? 2 pi is the same as 6 pi over 3. How far is 6 pi over 3 and 5 pi over 3 away from each other? 1 pi over 3. So pi over 3 is your reference angle. What is pi over 3 in terms of degrees? 60 degrees. 60 degrees. 495. Uh-oh. Now I got to go back to the very first section of the chapter and think coterminal angles. What's a coterminal angle with 495? You subtract 360 and you get 135. So which is the 135 angle here? A, B, C, or D? B. There's not even a D on there, Bierschbach. A, B, or C? It's B. 135. How far is 135 away from the x-axis? 45 degrees. So its reference angle is pi over 4. So that's reference angles. Negative 4 pi over 3 means we're going around this direction. 4 pi over 3 is basically how many degrees? 4 pi over 3, normal 4 pi over 3 is basically how many degrees? 240. So I'm basically going 240 degrees that way, which means I'm going 120 degrees that way, which means I'm at C, correct? Okay. But since it's a negative 4 pi over 3, notice how B and C have the same line. It's just B comes from this way, C comes from this way, and since I'm going a negative, this is the one I want. When you go negative, you're going clockwise. All right. So how far is 4 pi over 3 away from the x-axis? How far is negative 4 pi over 3? This line right here, how far am I away from the x-axis? 60 degrees, or pi over 3 in radians, which is 60 degrees in degrees. All right. Cosine of 120. No graph on this one, just what's our reference angle? Well, how far is 120 degrees away from the horizontal line? 60 degrees. How far is 5 pi over 4 away from the horizontal line in radians? Well, what's a horizontal line? A horizontal line is 4 pi over 4. So, like somebody said, yeah, we're pi over 4 away. Pi over 4 away. So I think you can do these, right? Ooh, 13 pi over 4. That's a good one to use. Okay. 13 pi over 4. Okay. What's a coterminal angle with 13 pi over 4? Well, we should really add 8 pi over 4 to find out. Because 8 pi over 4 is 2 pi, and I get negative 5 pi over 4, correct? Well, we add another 8 pi over 4, so I'm working with positive numbers. If we add another 8 pi over 4, then I get 3 pi over 4. So what quadrant is that in? Second quadrant. 3 pi over 4 is in the second quadrant. How far is it away from the horizontal line? 45 degrees, or pi over 4 radians. Okay. Oh, actually, they want the exact value of this. So I'm at 3 pi over 4 and I want the cosine. What's cosine of 3 pi over 4? Negative square root of 2 over 2. So I guess on this one, they wanted the exact answer for this one, not the reference angle. So the sine of 5 pi over 4 is negative square root of 2 over 2. Okay. And so here, the cosine of 120 didn't want the reference angle, wanted the cosine of 120, which is actually 1/2 with a negative, right? So, all right. Got those fixed. All right. This will be a test question. Like number 14 will be a test question. So know how to do it. What is the sine of 7 pi over 6? You can look at your unit circle to figure out the sine of 7 pi over 6. That would be 1/2. What about the cosine of 7 pi over 6? Oh, negative 1/2, sorry. What about the cosine of negative 7 pi over 6? Negative square root of 3 over 2. Now the tangent of 7 pi over 6 is the sine over the cosine. Negative 1/2 over negative square root of 3 over 2. We have a complex fraction. To get rid of a complex fraction, multiply by the denominator of the denominator. What's the denominator of the denominator? 2. So multiply by 2. You get negative 1 over negative square root of 3. Then a negative over a negative is a positive. And if we multiply by square root of 3 over square root of 3, you get square root of 3 over 3. So this is square root of 3 over 3. Cosecant. Well, that's the what of the sign? Reciprocal, not the opposite. It's the reciprocal. So it's negative 2. What is the secant? Well, the secant would be negative 2 over square root of 3, correct? Can we leave square root of 3 on the bottom? No, multiply top and bottom by square root of 3. You get negative 2 square root of 3 over 3. And cotangent, you flip over the tangent. So it's the square root of 3, negative square root of 3 over 2 over negative 1/2. Multiply them both by 2 and get rid of the negatives. This cancels, and it's just square root of 3. Okay? So you have a couple problems like that where you're solving them. And then this, which is the same thing, solving it. The sine of 315 is square root of 2 over 2. Cosine of square root of 3 over, this is negative. Cosine is positive square root of 2 over 2. Tangent is 1 with a negative. Cotangent's negative 1. Secant is the flip of that, which is square root of 2. And cosecant is negative square root of 2. Okay? So you'll have those for a couple problems. And then, finally, it'll ask you, are these equal? Are these equal? Okay? Well, the cosine of 315 is a positive square root of 2 over 2. Cosine of 45 is a positive square root of 2 over 2. Are they equal? Absolutely. Cosine of 156, cosine of negative 24. Now, you can't use your unit circle for this. You got to use your brain for this. Okay? We're here and we're here. Cosine of 24 degrees is the same as how far up here, except for they have what types of signs in the first and second quadrant? They have opposite signs. This says they're the same number but opposite signs. And the answer is yes. They're the same number but opposite signs. Okay? 3 pi over 14 and 11 pi over 14 for sine. So they're like there and there again, just like cosine. But what do we know about sine in quadrants 1 and 2? They have the same sign, so this would be false. They'd be the same answer because they're the same reference angle, but the sign was wrong. So you'll have 20 problems to work on, but some of them will take a little while. So today we'll just do 1.6. Tomorrow I'll review test on Tuesday. Test on Tuesday over chapter 1. I will have a sample test I'll put out there for the weekend for you guys to work on. I'll probably I can even put out the sample test today, just so you have a little more time to work on it.